Okay, Block D. This is kind of an extension of our lesson plans using scale factors. I'm going to kind of shed the scale factor model for a while and just talk about ratios all over again. Don't forget what a ratio was. You were comparing two things. So, for example, when we had said boys to girls, and we had given some numbers. For example, 10 boys to 11 girls. We have the colon method here. We also have the word to being involved. And then we have the one that was most popular, the fraction bar, still pronounced 10 to 11. So we've been doing lots of ratios for the past week or so. I want to graduate from that and do something different now. But the next part here is going to be proportions. Now I've talked about that, or I've used that word recently when we did things like measuring outside, finding missing numbers, doing recipes, all that type of stuff. A proportion, the definition here, is two equal ratios. Two equal ratios. I'll give you an example. Let's use that boys to girls thing. Okay, there are 4 boys to 6 girls in my classroom. Okay, an equal ratio would be, you could also do it another way. We could reduce it by dividing by 2 and say 2 to 3. Instead, reducing it. Or, believe it or not, and by the way, this is called a proportion. That's called a proportion right there. Or, we could also multiply, by 2 and say 8 to 12 by multiplying by 2's. So 4 to 6 or 8 to 12, same ratio, called a proportion. Or, let's multiply by 3 and say 12 to 18. So in other words, 4 to 6 equals 8 to 12. That's called a proportion. Or 4 to 6 equals 12 to 18. That's called also a proportion. We have what's called two equal ratios. And they're pretty easy to do. Once I give you one, you can either reduce it or you can multiply to make the numbers bigger, still called a proportion, whether it's large or small. But let's talk about making sure proportions are true proportions. To find out that 1/2 could also be called, for example, 3 over 6. Okay? Yes, you could say your scale factor is going to be 3. 2 times 3 is 6, just like 1 times 3 is 3. Or use a scale factor of 4 and get 4 over 8. But I want to go above and beyond that. To prove that you have an actual proportion without using the scale factor theory, there is something called A over B equals C over D. And the law goes like this. If you crisscross multiply the numbers that are diagonal from each other, see how I'm kind of clipping them together? Looks like a butterfly in the end. So notice that A and D, whatever numbers were in those positions, they're going to get multiplied together. And whatever two numbers are in the B and the C positions, those two numbers get multiplied together. And after you're done multiplying, if they end up equaling the same answer key, you have a proportion. Now we call this, it's not called crisscross multiply, although some people say that. It's called cross product property. Cross product property. So basically you do crisscross multiply, but you're making sure you get the same answer key. And then you can say, yes, I have a proportion. All right, let's put this into use. I'm going to do something like this. 4 to 16 equals 1 to 4. And the question is this a proportion? I don't know. Well, don't talk about reducing or scale factors yet. Let's use our brand new little technology here. I have now taught you to crisscross multiply the numbers. So 4 times 4, and the other two numbers were 16 times 1. Well, look at this. 4 times 4 is 16, and so isn't 16 times 1. Because both numbers equal each other, you have a proportion. So that's how you prove that two ratios make a proportion, by doing cross product property. How about example number 2? Let's do a ratio of 28 to 35 equals 4 to 5. And pretend right now we have no idea if this is a proportion. Well, I'm not doing scale factors. Instead, I will do the new thing called crisscross or cross product property, crisscross multiply. So I'm hoping that 28 times 5 and 35 times 4 equal the same thing. Well, I've done the workout for you already, and both equal 140. So check, you have a proportion. If someone says, how do you know? You don't say about scale factoring any longer, talk about the cross product property. Or better yet, a larger one. 78 boys to 44 girls equals 18 boys to 11 girls. I want to find out if this is a proportion, so I shall do my cross product property. So 72 times 11 and 44 times 18. I did the workout already, and you get 792 on both of them. So yeah, all three here were called proportions because of the cross product property. Three more. Try this. 2/3 equals 3/4. Write that down and tell me if it's a proportion or not. And then try 3/5 to 15/25 and see if that's a proportion. And then 4 to 3 equals 6 to 5. All right, I'm going to ask the sub, please hit the pause button right now. Let the kids finish this, and then when they're all done, press the play button again. All right, now that you're done, I'll do the workout for you. So crisscross multiply, 2 times 4 and 3 times 3. Well, 2 times 4 is 8, 3 times 3 is 9. These do not equal each other. No, not a proportion. Number 2, 3 times 25 versus 5 times 15. All right, so one side is 3 times 25, the other side is 5 times 15. I'm getting 75 for both of them, so yes, this is a proportion. And last but not least, crisscross multiply, so 4 times 5 for one of the testing numbers, and the other one is a 3 times 6. 4 times 5 is 20, 3 times 6 is 18. No, this is not a proportion. So here's how you can claim something is or is not a proportion by doing cross product property. Okay, enough about proving that two ratios make a proportion or not. Let's now move on to solving the missing pieces. Solving the missing piece. And I have been dying to get this far ever since I've been doing this whole type of stuff. Let me give you the first example. And I think a lot of kids, maybe your parents already told you this as a shortcut. I just didn't want to talk about it until it was time. That's a question mark, by the way, up there. You know, I'm not going to do it. I'm going to hit the word X instead. So let me do this. Let me erase what I just did and put the letter X there instead. Okay? Instead of a question mark, put the letter X there. Now you could say, oh, there's a scale factor of 2. You're right, there is a scale factor of 2. Top and bottom. But I want to do something different. Instead, I want to do that cross product property again. But look at the format now. Notice that 3 and 14 make, I guess, a little butterfly wing, a piece of the butterfly. So I got 3 times 14. Now look at this spare 7 that connects with the X. There aren't two numbers there. So the procedure is the third number that didn't make a perfect pair, that's what you divide by. So you do 3 times 14 divided by 7. And I'll do it out for you. 3 times 14 is 42. Divided by 7, the answer is 6. So that's how you find the missing piece. Besides doing the scale factor stuff we did a while ago, you can now use the cross product property to find the missing pieces. So that's also how you get the number 6. This is the method I use more than the scale factor method. Example number 2. Do 15, how about use the letter M now, M for missing number, equals the ratio 10 to 9. So I got to find out what M is to make it a proportion. Now 15 and 9 are a pair. Those are the numbers you multiply. Then when you're done, you divide your answer by 10. Now 15 times 9 is 135, and 135 divided by 10 is 13.5. Okay, ba-da-ba-bum-ba-bum, we now found out that m is 13.5. So the ratio would look, the proportion would look like this: 15 to 13.5 equals 10 to 9. That's how you find out the missing piece. We do a couple more here. Example number 3. All right, 5 to 60 equals 3. How about I put x again? I'm an x fan. I'm going to keep changing where the missing number is every time. I'm going to first circle the two numbers that do make a perfect butterfly clip, the 60 and 3. Those are the two numbers you multiply together, and then when you're done, you divide by the last number available, which is 5. Well, 60 times 3 is 180. When you divide that by 5, you get 36. So you've now found the missing piece. So the proportion is called 5 to 60 equals 3 to 36. There's your proportion without doing scale factors. Let me do one more here. Example number 4. Something really easy. 9 to 3 equals m to 5. Okay, the two numbers you can multiply are 9 and 5. And then when you're done, divide it by the last number available, which is the number 3. 9 times 5 is 45. And 45 divided by 3 is 15. So that is a missing number to the proportion. 9 to 3 equals 15 to 5. So that's how you find out missing links or missing numbers in your proportions. I use what's called the cross product property. Okay, so that kind of concludes the whole lesson on cross product property. And here's the next part that we're going to have done. There's a couple of worksheets I want you guys to work on, and those will get passed out soon. I believe these do require some calculators. You're probably going to need to go get your assigned calculator and work on the worksheets using your multiplication skills, your division skills, your new cross product property skills, or whatever it might be. And this is not made for homework, so whatever you don't get done in class, I want it passed into the sub on the top tray again, and then we'll just continue on when I return. Okay? So I expect you to behave yourself and to treat our guests with the best manners possible. Have a great day, and I'll see you when I get back. Bye.